Hey guys, Eric in the alley again. Today I got my neighbor Ronnie. Actually, the guy built this garage, and he had a pretty successful body shop out of this garage, and for years. And yeah, the PT Cruiser, I got a video putting a timing belt on. It's his car again. He blew out a tire the other day, and then he says his power steering was going, and the tensioner's bad. I mean, it would be a coincidence, but I mean, burning a lot of rubber in a PT Cruiser, so you can't really see from the top very good. If you look down in there, if the camera's going to catch, you could see a back pulley for the alternator, and it's still attached. It has like a V-belt for the alternator, and then it has a serpentine for the power steering. You could see it from the side there. See the pulley? Well, I could barely see it with my eyes, so I know it's harder through the camera, but there you could see the top of the pulley right through this little hole here. There's no belt on it. Now, I just got it up on ramps, and from underneath I could tell that the plastic part of the tensioner shattered. So I just got the whole tensioner arm. You could just replace the pulley, but for what it is, these tensioners do wear out. Going to keep a good belt on there for a good long time, but keep it going. It's 2004 PT Cruiser. It's 2.4, I believe, non-turbo. I'm going to just jack it up, put it on some jack stands, and this is definitely going to have to go take off the passenger tire to get easy access, but it should be pretty simple. It's a 1-bolt pulley. There you go. It's got the front tire off, and this doesn't have a plastic cover on it here. It did. I don't know if the belt took it off or what happened there, but at any rate, I got the creeper out and I got under it, and we could see real clear that tensioner is. Let me get the light to a little better spot here. There's nothing left of that guy. That's gonna do it. But it's just odd that this tire blew and that belt blew. I mean, there is an angle here that the tire could have, the tread, because I'll put a picture. It shredded the tread. I mean, completely spun it. So, could it have hit the belt in here? I mean, who knows? But just a coincidence. I mean, things happen in the wintertime more than in the summer like this. But what I'm going to do is just with a trim removal tool. There's not many left in. I could only see one actually holding the front on, and then I could get a better peek of it back here. But what we have to do, because we can't see from the top, is just take that pulley off first, and then that'll let you see the bolt, because the bolt to get the tensioner off is up here above the pulley. I can't get a good view there, but it's up here. We can't see it. I could just feel it on top there. So we're going to take this off first and see what we're looking at. It goes, tried to get you up there in kind of an angle, but we could see without the inner fender liner there. And this is a 15 millimeter just on the pulley itself. You can't get a socket in here, so you need a wrench or a ratchet wrench. So you want to make sure you don't get the, like this. I'm kind of trapped in there and I have to push it forward. But let me show you. mean, this does happen a lot on a lot of these bolts. But if you're lucky like this, I could still get an open end on there and get my wrench back out. It's like using a socket and on a ratchet, and sometimes as the bolt comes out, it just gets caught in between the frame. So watch out with this. If you use a ratchet wrench, you're going to have to finish it off with an open end either way. Like that, and then just... There, that thing's pretty tore up. But the bolt does come out and it clears the frame. And then now if we look up there, let me grab the camera and move you up there a little. Now as we look above the tensioner, we can see there's another bolt. That looks like a 15 also. I'll check it, and what it looks like is a very shallow socket will work, or possibly the ratchet wrench again, but either way, we're going to see what fits on there, and I'll let you know. Because it's, if you have a close quarter ratchet or anything, this one, after it broke loose, it really wasn't finger tight, but that bearing was whooped. This one, if you could get them finger tight and undo them with your fingers, that's good, but this is the frame I was getting caught on right here. Okay guys, as you can see, you can get to it here and just turn it with just a wrench. So this is a 15 millimeter also, so and you might be able to get a shallow well ratchet on there, but what's interesting is to see if I could do this whole job with just one wrench, one 15 millimeter. Yeah, let's see if I can get that with my fingers. Alright guys, I got out the green board just because it looks cool, and I do want to point out first that this is made in Canada. So that's pretty cool. Thank you, our Canadian friends. This is a little bit better than some of the Chinesium stuff we get, hopefully, and this year Chrysler, that's probably where the original one was made anyway, so hopefully it's going to last another 100,000 miles. But the thing that we have, whenever we get under, I'll show you, the bolt stays in here. There's not enough room in between here and the frame to get the bolt out. So once the bolt's loose, we just leave a dangle in there. And what I'm going to do is just take a hammer or anything and hit the side of it. It's sticking on there now, but this piece goes into the block. And the thing that makes it a little bit tricky is whenever you look under there, this goes behind the pulley for the water pump. So you got to be careful you don't chip that pulley. I can't get the camera in there very good to show you exactly, but you're going to see the top. If you look above where that bolt is, that part is right behind the pulley. So what we got to do is knock this out of its hole and just slide it out like that. Alright guys, I'll see you under the car again. Alright, the visibility isn't the greatest, but if you could see the bolt right here, now that'll hit the frame. It won't come out the whole way. But if you look right above it, that's where that little ear goes to. But you could see a pulley that almost overlaps the tensioner. And that little ear is right behind it. So we don't want to pry out hard on the top or we're going to hit this pulley. So what I'm going to do is try to get that punch on here somewhere and just pop it, or get a pry bar anywhere on there. You can see it looks pretty galded. And right in here where all that white crusty stuff is, that's where that little round dowel that we want to knock out of the block is. So you could spray it if you want WD. I'm going to just hit a little bit of PB Blaster, anything like that. And, you know, not really going to leave it sit, but sometimes it does pretty good on that corrosion. Alright, I don't know how long the tripod's going to last there. And hopefully this doesn't fall right on it. Hard to get a good shot at it. It's nowhere to get a good rasp on it either. Trying to hit it on the back a little bit there. Oh, broke one end off of it. Getting some wiggle in it now. They just corrode very aluminum to steel. She's on there good. Very good. See, that's all the corrosion that was just holding that on there. Actually, I could break that stud off. Let me see if it's still in there. Yeah, see it? That little dowel, that round piece, is still in there. So that's how good these things stick on and corrode, because that's just a piece of aluminum and it's going into this steel bracket. So it's a real hard area to drill, but you know, there's quite a few different ways of getting this out of there, and we're going to just find the right one. All right, guys, first thing I did was I reached on behind here, and the hole goes the whole way through the steel, this bracket. So I took a cold chisel like this, and I sheared that off flush, just along with the steel. This is softer aluminum, so now what I'm hoping to do is just put a punch on that aluminum and knock it out the backside. Hopefully that'll work. I mean, without any heat or anything, just a simple tools. Unfortunately, I won't be able to get the camera in there to knock it through because I have to be right here. But what I'm going to try to do is, even though it's a little angle, get it started right up against the frame rail, a couple hits like that, and just punch it right through there. Oh guys, sorry I couldn't show it, but it took 2 little hits. I went with a flat one for, one with a broader tip, but I went with a sharper one for just 2 hits, and boom, boom, right through. So it's very soft. You see it blow through. There's a lot of corrosion in that hole. So I'm going to just spray that with some WD, leave it sit for a little bit before we get the new tensioner on it. But I mean, that's an easy way. I mean, you can move the motor around if you have to, but I mean, you know, nobody wants to get into that just for a tensioner. So you don't want to lower the motor enough to where you could get on that dead straight. But I mean, if all else fails, you could undo the engine mounts and drop the engine down. But I just wanted to get in there, even though it was on an angle, right from here on the frame, and just gave it 2 taps, and it went right through the back. So that's the best we could hope for, guys. So there's not much left of it at all. It spun the whole way around. Took out the main. I guess that would be the race, but it was connected with plastic spokes like that. It just sheared the whole thing off. Ripped that. It looks like I had a meltdown. And then on the back, there's the part I was after with the drift pin punch. I had to knock that out of there because this piece, that's what's stuck in that metal bracket. If that would have been a dead end hole, that would have been very difficult to get out. But being that's a straight through shot, and this is very soft metal, just pound it right through, put another one on. These type of pulleys, I mean, I've seen quite a few of them do this. It's like they don't give you much warning, but all of a sudden at once it completely spins. But put the new one on, and I'm going to put a little bit of anti-seize on there just in case this thing ever needs to be replaced again. Hey guys, these are just gun cleaning brushes. I keep a variety of them around just in the pack out box. You ever need to clean something like that, like I'm going to put a little bit of PB Blaster on this also. It's about 38 caliber belt tensioner, so I'm going to just run this there a couple times. They're softer than a battery cleaning brush, like a wire brush, but you know, you get them in there and you work around that PB for a while, at least you're going to get some corrosion out. All right, that's just about what I was talking about. Hit it. Now it's probably a little bit too much, but then you just move it in and out of the hole like that. Get the corrosion out. Just so, I mean, hey, it's good prevention to know that even if one galds in there like that one did, you know, you're going to still be able to pound it out of the back. See, that's enough to get it in there. I'm still going to put a little bit of copper anti-seize in there, and I'm going to clean up the face of that. All I could do is just get a little bit of sandpaper in there and, you know, clean it up a bit. You're not going to get anything air powered in there, that's for sure. But yeah, I have a bunch of engine rebuilding brushes that are around this size, but you don't want to waste them cleaning something like that for a belt tensioner. And these just, you know, lay around, they do a good job, and you could carry a bunch of them because they're so small. Just, these got me out of so many jams, even, you know, corroded trailer plug wires. I mean, there's all different kind of uses for them. So if you ever see them laying around, I wouldn't say go out and order yourself a set, but I find a lot of these at not really flea markets so much anymore, but yard sales, garage sales, things like that. All right, guys, it's real easy to bump the pulley off of the new tensioner because there's not much room to get that in there. So I just use the impact. If you just hold on to it, it's not going to go nowhere. It zips off pretty good. Now this is the back of it. I'm going to put some Loctite on the bolt. We're going to put blue Loctite. And then on the back of the actual tensioner itself, I'm just putting some copper anti-seize. And then that way, you know, peace of mind if you ever have to take it off again. If you live in a salt belt, you know what I mean. And see, guys, very thin with the copper anti-seize. And this is all the Loctite you need. It's just a very thin blue line. And that's all. You don't want it dripping off the other side. I clean the threads up with a wire brush and then just put about that much Loctite. Just drag it down there and just put a very thin line. Right, guys, very simple to put it back in there. You got room to start it with your fingers and tighten it with the wrench. I'm going to put the pulley back on next, and it, you know, it would have been a one wrench job if it didn't, you know, golf to the steel part. All right, the belt goes on with the same 15mm wrench on the tensioner. The trickiest part is just getting it up in between the frame and up on top of the water pump. But, you know, it's pretty simple from underneath it here. It's a pretty easy job to do. I do see an oil leak I want to investigate. Probably valve pan gasket, but we'll see. But other than that, if you actually broke a belt or replaced this, that's the way you want to route the belt. It goes up around the pump, down around the tensioner, around the crankshaft, over the AC compressor, and back up to the water pump. All right, guys, back down on the ground. Had that wheel off, torque it. Torque every wheel every time. All right, guys, this is what I, refer to as pirate waveforms. The car was in here for a tensioner, and then you do something. I mean, I've been itching to use the scope for a little bit. Seems like everything recently was, pulleys, alternators, a lot of things that were just obvious bad, a lot of suspension. So, I mean, it's nice to get it out and have a purpose for it. Now, in this case, it's trying out something new I've had for a while. Let me flip the camera around. I got these Rotkee, I believe these were the L4 that go on top of the coil. This, I think, was a C1. I'm going to have to look it up. But these, I mean, I had success. You get a signal on all of them, but I just haven't found the right, coils or situation where that'd be really beneficial. But this one I'm going to give a try. This is just to replace like the Handtech, I believe it's the HT25, this that just goes around the spark plug wire. And this has a ground. This does not. But this is not metal. So in a situation, something like this, I mean, it might make a difference on getting a signal. I don't know how magnetic or how good that insulation is. We have oil either coming from the valve cover or from the power steering pump. And there's wires right there. If you're going to clamp onto that with a metal one, I mean, you're going to just increase your chance of arcing. And if you're grounded, it's not going to hurt your scope, but you're not going to get a very good signal. So, always an experiment. So before I give it back to Ronnie, I'm going to just, hook up H-scope real quick and see what kind of signal that gets, because they do make a differential amplifier for that. And I was kind of looking into that, because even if you get a weak signal, if you could amplify that signal, like a low voltage signal like that, get really good waveforms through a wire, there's not too many wires left out there, but you know, just another piece of equipment that we could adapt to other things that we already own. See, that just clips right over the wire. No spring, no nothing. You just push the wire right into it and it retains it. And actually on this car, what's odd is you could get to all 4 wires through the intakers, 2 on that side and 2 on this side. So you'd be able to get a signal off all 4 secondary if you wanted to. Switch over to the screen recorder. Now this is going to turn into a little more than I was thinking and trying out, but I mean, I had a couple questions, so I'm going to just show you the quickest way I find to find a signal with 8 scope. If you just open it up from nowhere, even if you kill your apps, whatever, you're just opening up from a dead first time you fire it up. Now you should look at the bottom and your scope should be there. This should say HS512, HS502 reading. If you don't, if it says no device connected, check your cord, check from the scope back towards your tablet. But if this is reading and that's your 0, if you're going to take a precise measurement, I'd calibrate it. This is an inductive pickup, so we're not measuring, and this is where some of the confusion is. We're not measuring the big bang. What we're measuring is just, it's like ripple in an electromagnetic field. So we're not measuring high voltage. We're going low with no attenuator. We're just measuring its field through the insulation. That's why we go very low. I stay down with I'll start with a 1.1 volt. And I'm not concerned about the secondary spike. We're going to be more concerned about where the spark line is on that spike. If we're going to measure the primary, that is before the spark, the voltage is going to be very important. If we want to see the maximum output of the coil, the spark, it's too high voltage to measure. So what we do is we use, you can measure it, but you're going to do it a different way. You're going to either pull the spark plug off, the wire off of the plug, and move it until it doesn't jump the gap anymore. The last reading on your scope is the maximum kV output of that coil. Or you simply use a spark plug tester that you put into the spark plug wire, and you use it as the spark plug gap. And as you unwind it, it makes the gap larger. So you're not really looking for a secondary measurement on the spike, that is. So what I do, 150 kilosample on everything ignition, it seems to be the sweet spot. I always start on 150. If you're using 2 channels, you're going to want to go up to 300 because it'll split the channels at 150 each. If I put 1 channel on 300, I'll show you in a second, but this is oscilloscope mode. I put it on the longest amount of time. And if you go for a resolution, this is 8 milliseconds. So that's a very short screen. This is not automotive mode, but this is live. This is what you're seeing on the car right now. No recording, or on automotive module, you have to record and then play back. This is where I start just to get a good signal. I'm going to get in the car. Well, I'm going to just turn the key and let it run and just let it record what I see on the screen, and then I'm going to just deal with a pinch and zoom to get a good view. See, we're very, very low signal, the voltage of it. But we see we're inverted and the signal's everywhere. I'm going to turn on the exhaust fan and then I'm going to show you how to deal with this. Okay, our signal is upside down. This is a wasted spark system, so 2 are firing this way, 2 are firing the other direction. If we wanted to look at this the right way, what we'd want to do is go to filter and invert it. Now we're seeing a spark line, and it's staying pretty still by itself. But if you wanted it to stay stiller, go to the trigger, make sure you're on the right channel 1, and hit normalize. And it'll hold it pretty still. So you're basically seeing if it's firing, but more importantly, we see that we're getting a signal here. So whenever we move on to automotive module, we know we're recording. I'll show you quickly some of the cool things you could do. Now we're seeing this move around. As I was talking resolution, we'll double the resolution to 300. Put a normal trigger back on. Drop it just a little bit. But now, if you want to take a see, that's not only a good pickup I like seeing. It's, you know, the H-scope, I mean, it's deadly on secondary, and as long as you got the good pickup, you know, something will pick it up. But you see how it gets blocky here? That's just too much resolution for me. I mean, this isn't CAN bus, this is only ignition, guys. See how there's traces when you, I mean, that's a little bit too much resolution for me. And even going down like 150, and I'm gonna have to put the trigger back on. That's good enough resolution for me, and you see how we're not as blocky. And whenever you're in scope mode, the lower your resolution, the more time you have. Like we're on 150, but we could go 8 milliseconds. Now if we go to 300, four milliseconds. For secondary, yes, that would be okay, because you could still, you're still going to get your waveform. So now we know we have that. That's whenever I go to automotive module. I'm still going to go to 150. And you could record up to 6 minutes and 24 seconds. Now I'm going to hit record. And this is still the same settings. 1.1 volt. My filter's still inverting it. A 1x probe. 20 milliseconds per division. And I'll just give her a little bit of rev, then shut it off and see what we got. Alright, stop that. And just for, this is where you save them. I won't name it right now, but just in case you get knocked offline or anything like that, you could just reopen H-scope and you have the file. That's once again excellent on both accounts for sparkline, because some of the built-in tools, just be an example. Oh, let me close that. You could quickly measure your burn line, give you an indication of, you know, how long the computer's pulsing the injectors. I mean, point you in the right direction sometimes if you're running rich or lean what the computer's doing to adjust for it. 1.6 milliseconds at idle. I mean, that's a good, up to about 2.5, I believe. I'd have to check, and once again, you'd have to check exactly what system you're working on. But if it's shorter than 1, you know, that's when you really want to make sure it's supposed to be, or start finding that problem. When you're done with them, you just flick them off. I mean, this is a very easy, quick way to acquire a lot of data. And here's one thing that, you know, there's so many systems, I'm not 100% what's going on, but what I'm looking at is this is firing in the same direction. Sometimes you see an artifact from the other coil firing, or the same coil. Sometimes even the other coil. I mean, whatever's on the system. But this is firing in the same direction. I found this curious, and I'm not even sure I'm telling you the right answer, but it's just one way that you have a resource. With the phase rollers, I'll move to the actual spark line, the end of the... On the waste spark, it fires on the exhaust stroke, at the end of the exhaust stroke almost. So what we'd be looking at is number 1 right here. This is number 4, but we're going to just assume it's number 1 for simplicity. The one that we have the pickup on, we're calling number 1. It's firing at expansion, and then on the exhaust at the trail end, there's another. Now, you're not going to have a spark line like this because there's no air-fuel mixture, you know, and there's no compression, but it's firing at the end of the exhaust. And it's, you know, this actually shows you that could happen. Is that what's happening? I don't know. You'd have to look more into it before you just assume that. But it's a pretty cool tool that tells you this spark is happening after expansion on the end of number 1's exhaust stroke. So that's how a waste spark does work. Is that what we're seeing, or is this number 2 firing? That's where you'd have to put in. If you were going for that mount and you go to the settings, that's where you'd put in your firing order, and you could really chase that down. You know, but I'm just showing you what you can do quickly on a run. I just intended to test out this Rotkee probe, and I mean, I'm really impressed. I like it. And whenever you're done with anything, even like this, just with your finger or the mouse, just flick it off the screen. It's a very, and this is just pinching and zooming. You're not setting up scales. I mean, I used to think a U-scope was fast, and it still is. It has its purposes, but I mean, to get a signal and get rolling, that's how I do it for ignition. It seems to work up to the point of the limitation of what I'm using for a probe. Some work very good, some don't. The inline ones, the L4, you know, I wasn't as pleased as this, but this, I mean, this is a replacement to that HT25. All right, I just wanted to clarify, like what I was saying before, on secondary, that I'm not watching this KV spike. On secondary, I'm really not. This is under acceleration. I mean, that's whenever, if you see a lot of them not picking up, it's secondary is fickle. You do get some very good waves like that, but would I take this as a reading on the KV? No, because it's still firing. Where it's firing, right here, secondary is still very good from this point on. The firing, I mean, if you see a consistent amount of low ones, like this, it fired and it actually fired a little bit rich. The KV wasn't high, but we're under acceleration down here. That's not an idle KV. So the varying RPM is going to change that. That's where your spark line, I mean, this is where you'd be looking for a misfire. But whenever you see one or two like that, there's a lot going on in there. So don't take this, as any indication. There's a lot of turbulence in there, and, tune-up takes care of a lot of it. But we could still see they have lean upticks at idle, even under RPM. It had some, but it's pretty impressive. It's definitely going to find you one that has no spark line. Like that, that's perfect for me. This matters, how it's being pulled down and, slight ramp up to the KV spike, but I wouldn't be measuring this with secondary. It's possible you can. The oscillations, we're counting things like that. The KV, at the end of this, I'll show you, what one of them spark testers looks like if you actually want a KV reading. All right, guys, that was mainly a test. This so good of a signal this got off of like a DIS system. I was pretty impressed with it. I like the way it picked up the signal. Anybody with H-scope, I know if you tried the HT25, a lot of times these will, crash it. With the attenuators, you have a little bit more luck, but sometimes it's, just a fact of life. This didn't knock H-scope off once, so that's a very good sign. I'm very impressed with that. And I don't want to say like the secondary KV spike, I don't want to call that like a useless measurement, because you can tell things, and I'm sure like, when you get in a scope, there's people use different things to diagnose different ways, put it that way. Some people, for instance, they love pulse sensors, and then you watch some videos, some very good people say they don't trust them, they won't use them. It's almost like everything you find, so you got to find what, if that's what you use, hey, I don't want to take nothing away from you, But this is the way, if I wanted to check the total output, just one of these spark testers, put that to ground and just keep turning it and making the spark jump the gap. And it has the increments of the KV on it. So you could just keep going and manually watch till you don't see a spark in here. Or if you are hooked to your scope, as you unscrew this, watch to where you get no spark. Where it doesn't fire, that's going to be your highest KV rating. But you're going to have some kind of scale to go off of. I didn't look up a spec sheet on this. I don't think there is a way, because better insulated wires are going to give this a different reading. So mainly what I'm looking at is that burn line. I'm looking at whether it's rich, whether it's lean, and where on that KV spike that the burn line starts. Does it start real high? Does it start real low? And look at that uptick at the end. Look at the oscillations. You could see a lot with this. On primary, you're dealing with actual voltage. So you want to attenuate, and you want to, it's more important to KV spike into the primary, watching the coil collapse. Because if you had a problem in the secondary, it's going to be mirrored in the primary. If you have a problem in the primary, it's going to be mirrored in the secondary. But, your actual voltage number where you need to attenuate, or you're going to deal with potentially high voltage, is on the primary. The secondary, we're in millivolts. That was on a 1.1 volt scale, and I still had to zoom in. So we're in very small millivolts. A 502 would probably be more at home in that 512, for a signal that low. But I mean, I was very impressed with H-scope, the signal I got with it. So all in all, that's an accessible experiment. This is $8 on Rotkee.com. I'll leave a link down there, and just send a little bit of frustration if you use H-scope and you get a lot of crashes after you get a signal, But again, too, something else that I thought about, this is a thing with scopes, so that they just keep progressing as you go. Ravi Fix with a coil over plug paddle probe was getting knocked off H-scope, and that indicated a problem, a big magnetic collapse that wasn't happening inside the cylinder. So it was knocking him off H-scope. So a lot of times when we get knocked offline with this, is this indicating a problem? I mean, there's just one thing after another, and just take it slow and don't go down a rabbit hole. That was one experiment. Take them slow. All right, guys, thanks a lot for watching. Hope you enjoyed that. Adios.